Namaste, hope you are doing well. Today we will solve the 26th question of ISI MSTAT 2024 PSA. And it's a least square theory, a regression setup based question. And I have a feeling that most of you, when you look at these options, you may recollect some standard textbook and already know the answer. But in case you don't, stick with this video. And we are given a setup of simple linear regression, only one dependent and one independent variable. We are given the error, and we are given three statements related to the error, that the mean of these errors, error is the wrong word, residuals, the mean of these residuals is 0. The mean of the residuals multiplied by the independent variable is 0. And the sort of covariance structure is also 0. We have to assess which one of these options are true. Now, we have to connect some dots. We have to first know what does the expression for the residual error actually look like. And it's this, actual observation minus predicted. And here in this case, the predicted observation is going to look something like this. It's a least squares model. So a simple setup like this. And what are going to be the estimates of alpha and beta hat, alpha hat and beta hat? What are they? They are these. Now these are standard things associated with the simple linear regression that are expected to be remembered. These are the values. And hence in light of these values, we can get the residuals rewritten as something like this. I do not hope over here, this thing means this summation minus x bar and y bar for observed data. And this thing means basically the empirical covariance and variance. Okay. Now we can compute. Let's evaluate this thing. If we substitute EI with what we have over here, we can write it like this and this. Now this summation, this would go to ny bar. This, it's a constant, so it gets multiplied ny bar. This becomes 0. And xi minus x bar, same thing. This becomes an x bar and this becomes an x bar. It cancels out. And when you multiply bi and xi, you get a structure like this. Again, something similar happens. Notice that from here, you can take the summation inside, and because y bar is a constant, it would come out and you have something like this. This is anyway x bar. And in this case, we have the summation inside, and x bar is a constant, so it comes out of the summation. And this thing again is x bar. So this thing becomes the variance. Variance cancels out. This thing is anyway the covariance. So we have covariance minus covariance, that's 0. And that's it, all are true. But wait, I did not evaluate the second one, right? But I don't need to evaluate that. And that's because when you look at the summation, E bar is already 0, so remove it. So what we have is summation EI xi minus summation x bar EI. X bar is a constant, it comes out, it again becomes a summation of EI, appropriately scaled, of course, that becomes 0. And this thing we found to be 0. That's it. And the base to build your basis, utilize the value of zeros. In this case, we saw that we found this to be 0 and this to be 0, and that helped us calculate this thing to be 0 without actually going into the depth of the calculation. And if you like this, then do share a situation where you initially expected something to be useless, but it did turn out to be useful to solve a problem. Take care. Hare Krishna.